Hello, my name is Kenny Gorman. I'm the product owner for Stream Processing. And today I'm going to lead you through a little bit about how you can easily build and run Flink SQL jobs using SQL Stream Builder. So just to kind of give you a feeling for what we're talking about in terms of the software we'll be using in the demo, we're using the stream processing and analytics capabilities within the Cloudera stack. So that includes Apache Flink and the SQL Stream Builder component that lives on top of it. And this is fully integrated across the Cloudera suite. I'm just going to be showing the stream processing and Flink pieces today, but know that it fits in and snaps into a greater ecosystem within the Cloudera stack, including management around metadata, schema, security, governance, and more. So it's an entire suite. I'm showing you a little bit of it here that's circled, and let's jump into it. So if you're not familiar with SQL Stream Builder, you're probably familiar with Flink SQL. And just to really touch on at a high level before we get started here, why do we need SQL? What's the purpose of SQL in this ecosystem, and why do we think about SQL? Well, the bottom line is that SQL makes development faster in a lot of cases. Not always, but in many cases it does. Even if folks do know Java, sometimes you just want to explore the data, poke at it, understand it, maybe create some quick aggregations. And then maybe actually you have a whole team of people that are coming from a reporting and analytics background and they know SQL already. Wouldn't it be great if they could participate in making stream processors as well? So that's kind of where the idea came from. Flink and SQL have been good friends for a long time now, and SQL Stream Builder, as I'll show, builds on top of that. Okay, so just to kind of orient you towards what we're going to be looking at here in a second, I'm going to be showing a demo. Just want to give you a little bit of kind of insights as to what SQL Stream Builder is and how it works. At a high level, it runs Flink SQL. Okay, so it's an interactive interface that runs Flink SQL. It allows you to easily build and deploy jobs. Like I said earlier, it's built into the Cloudera stack from a security and governance, from a runtime perspective, and functions seamlessly within with that stack, like, for instance, reading from Kafka or writing to Kafka or reading from Hive and Kudu, that kind of thing. So that's how it snaps into the ecosystem there. So it allows you to immediately deploy these jobs. You just hit execute, it runs the job, gives you results, and you're allowed to sort of iterate and play with it, and then build a production job that suits your use case. A typical data flow kind of looks like this. I kind of think in your head about, we're continuously running SQL. This audience and this team will not be surprised that we're running essentially Flink jobs underneath. So those run continuously. With a typical database query, it would start and finish when it's completed reading the cursor. Continuous SQL doesn't work that way. It's boundless. So it runs until there's no more stream or until it's canceled. The system also does understand batch data, so that's something that's quite different than other solutions in this ecosystem. Coming from a Flink development background, you'll understand that because there is the batch and there is the streaming APIs. And it really allows you to join using Flink SQL things like Kudu or Hive and with things like Kafka. So for instance, if you're joining maybe orders, you're getting orders flowing in through Kafka and you want to join those with employee records, or customer records. Okay, so pretty common pattern. And then on the outside, so like that's the source. Kafka is a very common one. Sometimes it's files, sometimes it's change data capture, and I'll get into that. But other times it's just simple Kafka, and then there's a sink. So a lot of times we'll process it down to a simple database, or maybe we send it back to Kafka for another processing in a chain, or save it in files, or even maybe use a webhook to call out to some sort of microservices. So you can see this is just kind of an example of, it's complex example of, how you can join, filter, and transform all in one statement, right? So in this case, we're joining geo events, then driver information, then we're looking up, stuff from timesheets, and we're putting that all into the location of a driver and a vehicle. So pretty complex join, but this is the kind of thing that you can do in a streaming context when you're thinking about SQL. Okay. So we also support materialized views. This is something that's not specifically Flink SQL. So materialized views, typically there's an impedance mismatch between when someone wants to, say, run a query and then present that query like in a map, say, like that previous example, we want to show positions of a truck in space or a truck on a map. How do I freeze or how do I pause that data stream enough such that I can read it with, say, JavaScript in a Google map, right? So JavaScript API isn't particularly good, nor is that lightweight API or lightweight programming interface good for consuming streams. So what do you do? And the answer is materialized views. And that's really where they come in. There's a number of vendors out there doing materialized views, and we do them as well. Ours are quite unique, and we'll talk a little bit about that, and I'll show you a little bit of that in the demo. But essentially what you're doing is you're running a SQL query, you're creating a materialized view, and then you have connectivity options from a variety of different things like Tableau or Grafana or data science notebooks or data viz or whatever that might be. So a little bit of details about the architecture, if you're interested. We are pulling from materialized views, we are pulling data from a retract stream. We're indexing that in the Postgres engine using gin indexing. We allow query by key, so that's pretty cool. We'll continue to grow that. We're now, it says here in V1 design, we're actually in V2 or more now at this point. And it allows you to then, appear with this retract stream is called a push query, and then you're allowed to then create a pull query. So developers and applications can query by any predicate. They can query that Postgres compatible database engine or REST API and build applications. Just to point out, this isn't a general purpose DB. If you wanted to, I'm just going to go back here. If you wanted to use a Flink and SQL Stream Builder to write like everything you've ever seen, like every transaction to a database, you would use a sink. That's the best, most effective way to do that. If you just want to power an application, maybe you don't want a DBA, maybe you don't want, to use a giant data store. Maybe you just want to present the last, 30 seconds or a minute or a day of information out to an application. That's when materialized views become more prevalent and more important. We do automatic indexing, automatic data pruning. It creates and manages the database for you end to end. So it's a really nice capability that's just self-managed. So if you want more control and you want to save more data or have a different architecture or whatever, you always can write to a database sync. But in our case, we've had this helper here to solve most of the common use cases. Okay, we also have integrated change data capture. So this uses the Debezium connector and connects directly to a database source. So this could be, let's say, Oracle or Postgres or MySQL. We have the Debezium library embedded in Flink, and so you don't need Kafka. You don't need a connector. You don't need a lot of other moving parts. You can just connect to the source DB, perform SQL queries on the CDC change stream itself, which is very cool, and then output to a materialized view or a sink or anything else like normal. Now, one thing to point out here that I think is really important is that you can run queries on that CDC stream directly. So that means, a normal use case would be, hey, I'm reading a change records from Oracle, and this is an employee database, and everything that changes in that database then goes into, say, Kafka or something. Well, now Kafka has to take the brunt of that change stream. It has to have enough storage. It has to have enough capabilities to store it all, and it's quite complex. But what if I don't care about all that data? What if I don't care about when the events change to nulls, or maybe I only care when an employee gets added. I don't care about when they get a raise or something. I can just put that in my query. I can select star from CDC stream where employee equals blah blah blah, or employee start date equals blah, or whatever that might be. So very, very powerful capability. And it can even join, by the way. So very powerful capability in the CDC stream to write a Flink job that directly connects and runs CDC from Flink, and that's built in. And I'll show you a little bit of configuration here in the demo. Okay, so let's jump into the demo, show you some cool things, and then send you on your way. So, okay. So I'm just going to start a fresh console here. This is the console that you saw in the slides. Just to kind of orient you, this is this will be running on your cluster. This is SQL Stream Builder, and it just launches Flink jobs, right? So it's helping you compose and manage Flink jobs materialized views, some session and settings information, and giving you and spooling output to you. So it's a nice interface for doing that. So let's just start off creating some stuff. I'm just going to kind of use this as a template to copy and paste stuff, so bear with me. Okay, so what we're going to do is, the first thing we're going to do, I want to point out, is that we have a session here, and we can set anything having to do with that session. And in this case, I want to set default parallelism. So let's just do that. Now, one thing that it did that's kind of cool is, even though this is a continuous SQL engine, it ran it knew that this wasn't a continuous query and just ran it, set it, and returned. So it also handles the batch scenario where something is more like a regular database query. It understands the context there and will finish and not continue to spool the data like it would if it was a stream. Okay, so now let's create a table, and this works very similar to Flink SQL. In fact, this is the Flink SQL grammar. And what we're going to do is we're going to create a table called orders, and we're going to drop it if it exists, just to kind of be tidy with our system here. We're going to use the faker connector, which is similar to the Java faker, if you're familiar. We're going to create some data here, some fake data. So let's go ahead and execute that. Like I said before, this creates things that are and works with things that are bounded. So it ran that and finished. There's no stream involved. It's just creating that table. So I can look over here in tables, and I can see that we have one called orders. Okay, so it created that for us. That's nice. Now let's go ahead and let's just run something here. Let me, I'll just start here. I'm using VI mode if you wondered. And then let's start a job. So what happens here? So what's going on here is I'm selecting from orders. You saw me create the definition of orders. Okay, so it's just fake data. It's spooling back that data. So this is not all of the data. This is just a sample of the data. You can see here it's sampling. Let's go up and let's look at the job it created. So it started a job. We can go ahead and look at the Flink dashboard for that job. Right, so it's relatively simple. Okay, not a lot here. It honored my parallelism. It started the job. Pretty simple stuff. Okay, so that's a typical Flink dashboard. Nothing special there. You can see it's a version that has to do with our build, but that's about it. Okay, so that's running and sending back the data. Okay, cool. But what if we want to do something with it? That was easy, by the way. And if I wanted to manipulate the data in some way, like I wanted to say where order time was some particular place, or street address was something. Obviously it's SQL. I can just type that in and do whatever I want there. Okay, so you could poke at it and reason about it and come up with something that you think fits your purpose and keep moving on. All right, so let's do something different here. I'm just gonna stop that job. And let me just start in a window here. And what I'm going to do now is let's create a view. So if you're familiar with SQL Stream Builder 1.4, we didn't have views. We didn't have the notion of doing so much DDL. And it's really nice now to have this kind of DDL interface. So I can just paste this in, create view summaries. What I'm doing now is I'm doing a tumble window. This should be familiar to a lot of folks in the Flink ecosphere. I'm doing it over an interval of 20 seconds. And I'm returning, I'm grouping by these various attributes: window start, window end, and then order status. And then I'm simply counting and summating the number of them and the amount of that they are. Okay, so that simple view, that view returns, it's finished. And now I can select star from that view, right? So I can go, let's go here. I'm just going to actually create a new window, select star from summaries, run that. Again, starts a SQL job here in Flink. That job can be controlled again from session settings here. Any Flink configuration value that you would normally assign to Flink works as well here. Okay, and cool. And while that's running, let's talk a little bit about the feature set here, just within the window itself. So. Like I said, you can look at the session variables. You can reset the session. You can use these as templates to set things within the SQL window session here. You can set some sample behaviors here. You can also set persistent job parallelism threads here and control some of the sample counts and window sizes here. Don't know results yet. Oh, did I stop the job? I think I stopped the job. That was, yeah, let's go back and run the job. I actually stopped the compose job. So let's go here, go back here, and we will get that running. Okay, so let's talk a little bit about Kafka, and we can talk a little bit about sources and things here. So let's let me show you this. So a couple different ways of doing things. I showed you earlier the tables. I created orders and I created summaries, but I didn't talk to you about airplanes. So let's just dive into that real quick and I'll show you this. So this is a table that represents a Kafka topic as an input. I've named it airplanes, the same name as a topic. I've got a local Kafka instance, but I've also got a remote one, okay? And so that remote Kafka connect string is actually saved out here in data providers. So you can actually connect to any cloud provider or AWS or whatever you want. So that's what we're doing there. Go back here. It's got a listing of all the topics. It's in this case, it's a JSON format that I'm looking for in that topic. And I'm going to go ahead and detect the schema. And what that's going to do is that's going to go out and read and duct tape and infer the data from both using the JSON data type and then actually reading the topic. So it pulls back, it understands that I've got a variety of different things in here, and it builds my schema for me. If this was nested or complex types, it includes those as well, so things like arrays and maps, things like that. One thing in here that's interesting is if you pull back something named timestamp, it will tell you that you can't do that because it's a reserved word. So I'm going to take that out just to kind of show you that. And interestingly, it also does syntax highlighting. So if I get that wrong, like that comma there, it's going to highlight that for me, give me a chance to fix it. And there's robust control over timestamps. It wouldn't make much sense if we didn't have that. You can either use the Kafka timestamp, as I am in this case, or you could specify a column if that made sense. We also can use transformation. So if I wanted to use that timestamp column and I wanted to rename it so it would be a reserve word, I could rename that within transformations here, a little bit of JavaScript code, then present it as a timestamp column and it would work as in the schema. But instead, I'm just going to use a Kafka timestamp. That's the easiest way for this. Okay. I'm going to close that. I've already created it. So let's go back to a fresh compose window and let's just show you what's in there. Select star from airplanes. Again, starts a job. You can see it's running and starts pulling back data. Okay, so this is just like pretend aircraft data that's being generated. A lot of demos have this ADSB data now. That's exactly what this is. So this is just raw ADSB data. Okay, so that's how you connect to Kafka. That's how you can use a Kafka source. It created that table for me. So it's just a little helper. If you actually go here, if you go here and highlight it and you click on DDL, you can actually see the DDL it used to create it. So I could have just pasted this in the window as well. It's just nice to have that little helper when using Kafka. It's the most common use case and it works great that way. Okay, so that's kind of how sources work. I showed orders, which is essentially a faker. I showed connecting to airplanes and getting some real data from Kafka. I showed creating a view for summaries. We talked about that. So let's do an output now. Let's send some data out to Kafka. Okay, so maybe what we'll do is we'll send the order data out to Kafka. So I'm going to create a compose window here, and let me pull up a bit of data here. So what we're going to do is let me show you templates real quick before I do that. So templates is the way that you can build this DDL. It's just a helper for you. Instead of typing everything out, it could be long and arduous. These templates help you just like plug in various sources and things. So like in the case of faker, right, I can just pop that in there. This is VI mode, so escape DG, deletes it, escape I can insert something, and I can switch that on and off. So if you see me jumping around and things are magically happening, it's because I'm using VI mode. You can also do file systems, so things like HDFS with Avro, JSON, CSV. You can connect to Kafka, obviously. You can just print the output, things like that. Now, I'm using the community version here that does not have CDC, so there's CDC templates as well. as well as automatically connecting to an internal Kafka cluster that's secure within the Cloudera stack. So there's a couple more options in the CSA 1.5 version, enterprise versions that you'd normally buy. Okay, so let me just go over to my little examples here, and let's just do this. And that's too much. Okay, here we go. So there's a lot here I want to talk to you about. So what we're going to do is we're going to create a foo topic output, and it's going to have the various attributes of select star from orders. One way we can do this, so this is pretty cool. You can say select star from orders, okay? And make sure that's a table, right? Yeah, orders. And okay, so that's my query, and that's the thing I've been working with. But now I want to send it to an output. So let's go down to template. Let's go down to Kafka, and let's say we're going to output it in JSON. It's going to go ahead and understand that select star from orders has a number of columns and has a number of data types associated with each one of those columns. And it's going to then pre-build an output for me and give it a generic name. I'm going to rename it topic, foo topic. And it's all built for me. So in this case, let me just get the right bootstrap server here. So it's going to be named localhost. I think it's Kafka 9092. Let's do this. Put the connect string in here, and the topic is foo topic. Okay, so that's simple connect string. You can obviously set all these properties. It's a proper Kafka client, and it's the same Kafka client you'd use if you were using Flink. So nothing special there. It just makes it really easy for you to do it. So let's execute that. And so, cool. What it's doing is it created a table. I think in the results, in the logs, it should show us this. It starts it. Okay, now it's running. Display next. Okay, so if you go over to results, you start seeing the results. That's fine. But where did the data go, right? I created this output table for Kafka, and where did the data go? So let's do this. Let's go insert into, I think I called this foo topic, select star from orders. Okay, so let's stop. Actually, this is going to table if exists foo topic, and then we'll create it again. How's that sound? So now we rerun that. It's going to drop the table. It's going to recreate the table. Now it's inserting the data into foo topic as select star from orders. So it's sort of an end-to-end. And you can also do insert into other foo topic, select star from orders too. If you wanted to insert and start redirecting data, maybe you even want to do it like this, where x equals y. Okay, so this is all Flink SQL stuff. The grammar is well known. What you're getting here is a super nice interface. You're getting the materialized view capabilities. You're getting a lot of helpers and templates and things like that. So this is making it a lot easier for you to reason about this data and build these processors. Okay, so that's kind of a pass-through, one-shot pass-through, and we'll talk a little bit about materialized views. Okay, let me stop that. Okay, let's see if we have any jobs running. So we do have that one. Select star from summaries. Let me start one that just says select star from airplanes to give you an example here. Okay, let's say I wanted to run a job that was just, like this, select star from airplanes. I want to just spool all the airplanes out to a map with their location. One thing I could do is I could then create a materialized view. And let's say I want to show this in Grafana, okay? I'm not going to do the entire thing here for you because it's a longer demo, but I'll show you the nuts and bolts of getting this connected, okay? So here's the query, select star from airplanes. It's a push query. Okay, so I'm going to take lots and lots of data. I'm going to distill it down to something much smaller so I can use it in my application. So I'm going to click on Materialized View. First thing I'm going to do is enable it. Then I'm going to pick a primary key. Okay, so in this case, I'm going to use iCal, which is essentially the tail number of an airplane. I'll give it a little bit of a buffer here, retention seconds. This is what determines the difference between using your database, like a big normal enterprise database that your DBA would manage that you probably have in your enterprise already, versus just using this helper as a materialized view. So if you start to think, this needs to be really big because I want to store everything ever, you're probably making the wrong choice. You probably then want to use just a regular database. But if you're using relatively small space here, this makes a lot of sense for applications and dashboards and graphs and things like data science notebooks and things like that. You can ignore nulls. I think you noticed in the output before, there's a lot of nulls. You don't want a null that's updating a location, like if it becomes a null, like a typical IoT device, to update it to a null. So in this case, you just say like, hey, I want to ignore nulls on update. We can add an API key. Let's name it mine. We can give it some more advanced settings. Won't worry about that now. We give it a predicate. So I can actually, now I'm configuring a REST endpoint for this now. I can call this airplanes. And I could actually go like iCal, like this. I could actually allow drill down capabilities as well if you wanted that. So this is beyond Flink SQL now. Now I'm creating a materialized view. I'm just going to call it airplane. I'll just return, say, all the columns here. Kind of don't care. I don't need any filters or anything, so let's save that change. And now I have a durable REST API. Okay, so let's start that. A pretty simple job. And it builds a materialized view as well. So, I should be able to, probably won't be able to pull that up right away. Let's make sure the job's running. Okay, so I'm getting data. Let's go over here and let's see if we're getting data back. No data yet. Okay, so basically what we're doing is we're running this query. We're getting the data back like I was showing. Data is being pushed to a materialized view. And we have a REST endpoint that we can show it. And that can be used like in notebooks. For instance, like if you're thinking pandas in Python notebook, it's one or two lines of code to pull that into pandas. It's very, very simple. So that's how useful that is. And then there's the ability to connect via external Postgres endpoint using the Postgres WIRE protocol. So let me show that real quick. So let's hop into Grafana. So this is just a container running Grafana, nothing special there. And again, I'm not going to build a whole entire dashboard for you here, but I will show you how you can connect to the data source and build your own. So it works like anything else. We're going to use the Postgres WIRE protocol. In this case, I'll just show you this one. I'll edit this one. We're connecting. I'm using this in the container environment on my local machine, so it's just Postgres 5432. You connect to the Snapper database, the backend component that performs this is called Aventador Snapper. You give it a user, and you're good. It's literally that simple. And so now I can go over and I can create dashboards. Maybe I add a panel here, and maybe I want to just enter some SQL, and then I can start entering SQL here. And so if you want to know more about how Grafana and the SQL Stream Builder work, I have a blog post I will include. Let's see if I have it here. I don't have a tab for it right away here. I wish I did, but it is, actually I'll bring it up. It is called SQL Stream Builder Medium Grafana. And there we go. This is a blog post that I wrote. You can just Google for it. It's on the Cloudera blog. And it talks about all the different configuration options, how you concatenate keys for time, some nuances with timestamps, and then how to do the pull query and create graphs as well. So to kind of give you a feeling for an end-to-end system. In the demo here, I'm just kind of doing the basics. Okay, so that's a quick run through. Let me just talk about a couple of advanced features, and because I think we're getting close on time, and that'll wrap it for us. So a couple things here is we now have both user-defined functions in JavaScript, so you can create some sort of this is a test, and you can create an output, say your integer. You can add a string as an input, and then you can write a piece of JavaScript as a user-defined function. That's been around for a while. We've had that since the very first version of 1.3, or first Cloudera version 1.3. So that's been around for a while. Ton of videos and content and docs on that. So I won't dive too deep into that. But now we also allow user-defined functions in Java, and they work the same way. You do copy the jar to the server. You don't have to restart a reboot or anything like that. And then you can say select my EDF foo from whatever table, for instance, like that. So typically works like you would imagine in Postgres or any other normal database works. You can define those functions both here or write them in Java, and include them in your code. So really cool way to build better business logic and kind of grow things. Now, people use this in a couple different ways. Functions can be used for a little bit of business logic. They can be used, like we have one that transforms, distances, measures distances between geolocations, for instance. Some folks have maybe a bit of fraud processing logic in there. So it's kind of up to your imagination. One thing I'll point out is if you have a very small list of, enumerated list of items to join against, maybe you're thinking, hey, I only have, like, let's just take, for instance, states in the United States. That it's a slowly changing dimension. It doesn't change very often. So a lookup table would work very nice for that. UDFs work great for that kind of thing. So if you wanted to do a lookup and find out what state something's in, and you only had a enumerated list of 50 states, then that is a great use of a UDF, whether it's JavaScript or Java. But if it's something that changes more often, maybe you're joining orders with users, and users changes obviously more than once a day or whatever. That would be a great chance to save it in something like Kudu and then perform a join on the query with your orders topic. So a couple different options there. Either way, it makes it kind of easy. UDFs is very unique. JavaScript UDFs is very unique to this platform. I'm trying to point out some of the things that are a little bit different than Flink SQL. Same thing with Materialized Views. I kind of went over that. So a couple different options there for you as you get into it. Now, how do you try this? How do you try the software? How do you get your hands on it? So we are announcing very soon that the ability to run this in a community fashion, or community version. And so that's what I'm showing you today. That's what I've been using. This is something that you'll be able to get your hands on shortly. So stay tuned for that release date. All this kind of functionality that I just showed you is something that you can do and try on your desktop, and start building stream processors and using this functionality on your own. So that is it. I will be on the session for questions, Q&A, and I really thank you for your time today. It was fun showing you this stuff. And again, looking forward to answering questions. Thanks, everyone.